Hello, quarantine sixth graders. And speaking of quarantine, we just found out that school is not going to happen in April. Here's my cat. Thank you, cat. And so the best chance we now have of seeing each other is in May. We'll see where we go from there. Meanwhile, let's continue with distance learning today. And we're going to study another physical property of minerals. Our first clue was the Mohs scale of hardness. Our second clue was luster. And today we are going to look at something called specific gravity. For sixth grade purposes, we're going to be using density, and I think even in the book they just call it density. I'll spend a minute or two showing you the difference, but in reality, we'll show you how they're really the same thing. So, specific gravity of minerals has a very interesting formula. You take the mass of the mineral, usually being balanced, and then whenever you see something over something in a formula, you know that it is division. So we're going to take the mass of the mineral and we're going to divide that by the mass of an equal volume of water. And that's where things get a little tricky to kind of figure out. You have to figure out what the mineral's volume is, and we can use graduated cylinders and displacement for that. But then you have to find the mass of that amount of volume of water. Anyway, there is some small differences between density and specific gravity, but right here is how you kind of find specific gravity. You have to find the mass of the object as it is suspended in water. It's a little tricky to kind of get correct, but with interesting setups like this, where there's our substance and here's our balance, if you're suspending it in water, you can find its specific gravity. Um, Old diagrams show setups like this, where you have to kind of use an off-scale balance and little weights here to kind of figure out what your mystery's substance's specific gravity is. But here's the thing. When you are finding the mass of an equal amount of water, you are basically dividing by that mineral's volume. And that's because you're comparing it to water. And water has a density pretty darn close to 1. I think it gets as far as 0.999999998 or something like that right there. It doesn't quite get to 1. But even at higher temperatures, it's still 0.996. So essentially, you're really close to dividing by 1. So whatever water's density is 1, and that means if you have 5 milliliters of water, you have 5 grams of water. If you have 2,700 milliliters of water, you have 2,700 grams of water. So if you are dividing by a substance's equal amount of water, you're basically dividing by its own volume. So when we find the mass of the mineral divided by the mass of an equal volume of water, you are ending up basically doing mass divided by volume of the substance, and that gives you density. So for sixth grade purposes, we're going to use density. Now, densities of minerals can run a wide variety. Something like mica can have a low density of around 2.8. Most metals are somewhere in the neighborhood of 7. And some very dense minerals like gold have a density of upwards of 19.3. So, just like there are luster collections and Mohs scale of hardness kits, there are actual specific gravity kits where you can kind of compare ranges of specific gravity. These aren't used as much as just finding the mineral density, but they are available. So, for today's review questions, you're going to be asked to find the specific gravity or density of a couple of mystery substances. So, just a reminder, you'll see a problem like this. A mineral has a mass of 2 grams and volume of 8 milliliters. What's its density? Well, if you remember from the first quarter, density is equal to mass divided by volume. And so we will find the mass, 22 grams, and put that in for mass, and the volume of 8 milliliters. So we're going to divide by 8. And when you do 22 divided by 8, you'll get a density of 2.75. And our instead of cats per donuts, we will do grams per milliliter. Most of my problems today will give you very easy numbers like this. I'm going to try to set it up so you don't have to do any kind of weird rounding or anything like that. So if you get a really bizarre number on your calculator, go ahead and go back and rewatch this to figure out what you're doing, what you're supposed to do. So, after three properties, our big giant game of Minerals Guess Who just got a lot smaller. We started off with over 2,000 possibilities. And after three clues, we could be down to less than 10 or so possibilities. The more information we gather about a mineral, the better chance we have of identifying it. That's it for today. We're going to allow you to use a calculator for today's review questions. Just open up a tab. There's plenty of online calculators out there that are available for you. Meanwhile, Gidget and I would like to say bye-bye.